Hi, this is Mrs. Minowitz, and today we're going to be talking about two different topics. The first one that we're going to be looking at is pure substances and mixtures. So pure substances are matter that cannot be separated by physical means. And pure substances fall into two groups. They are either elements or compounds. So pure substance is something you can't separate and get two different things. You can't divide it or break it and break it apart into two different things. So some examples are elements. If you look on your periodic table of elements, there are 118 of those. Things like hydrogen, helium, carbon, oxygen. Those are all elements, and they would all be pure substances. I can't filter oxygen and get something besides oxygen. Compounds also fall into this group. An example of a compound would be water, or H2O, two hydrogens bonded to one oxygen. That is bonded together. I can't separate that hydrogen from that oxygen by just filtering it or boiling it or things like that. They are bonded together. They are stuck together. Both elements and compounds are pure substances. Mixtures, on the other hand, are composed of two or more substances that are not chemically combined, and they can be separated. That is the key piece here. Can be separated. Some things that you might think of that are mixtures would be like salt water. If I put salt water on the stove, the water is going to evaporate and the salt will be left behind. I just separated my salt from my water. That is a mixture. Other things you might see together. If you look at sand and all the different types of rock within there, those are mixtures. You can separate them. They're not chemically combined. So what I want you to do, is you have a list of 15 different things, and I want you to tell me whether it is a pure substance or mixture. So go ahead, pause the video, try to work through those. The ones that are pure substances, you also want to list if they're an element or a compound. So I want you to pause and do that right now, and then we'll come back and go through the answers. All right, so now that you've had a chance to take a look at that, we're going to go through and I'm going to give you, discuss some of those different answers. Okay, so the first one is helium. Helium is an element that is located on the periodic table. So helium would go into the pure substances category, and it is an element. Okay, you can find it on the periodic table. Okay. Your next example is hydrochloric acid. This is also a pure substance. It's HCl. Often when people talk about like very weak or very strong acids or acid 808 something, sometimes they're talking about hydrochloric acid. This is a compound. Okay, it is written HCl. The next one on your list was mercury. Mercury is an element. It is unique because it is a liquid at room temperature, which is unlike many other elements. The next one is salt. Okay. Salt is also a pure substance. Salt is sodium chloride, which is a compound. Okay. You can't separate the sodium from the chloride, so that is a pure substance. The next one is salt water. Salt water is a mixture. I could separate that. I could put my salt water on the stove, have the water evaporate, and my salt would be left behind. I can separate it. The next one is sugar. Sugar is a pure substance. Sugar is C6H12O6. That is a compound. Okay. That is a compound. It's not on the periodic table, but its parts are bonded together, so it is a compound. The next one is water. Water is H2O. That is also a compound. I can't separate my hydrogen from my oxygen, so it is a pure substance. Carbon dioxide is also a compound, CO2. We've got those elements bonded together to form a compound. It is a pure substance. Copper is an element on the periodic table. That means it is a pure substance. Coca-Cola is a mixture. You could let that sit out and have the water in the Coca-Cola evaporate and you'd be left with the other ingredients. A diamond. Okay. Diamond is actually made of an element called carbon. And so since it's made of an element, that what makes it a pure substance. Baking soda is also a pure substance. It is a compound. Okay. NaHCO3, if I remember correctly, that could be wrong. But it is a compound. Next one, granite. Granite is a rock. Rocks are mixtures of different minerals, which we'll talk about more in our next unit, and so that we could actually separate it and get different crystals in it, so it is a mixture. Minerals are pure substances. We'll talk about that. They can be either elements or compounds, depending on the type of mineral that it is. Oh, but I skipped one in there. That's air. Air is a mixture. I can separate out the different gases from air, so that means it is a mixture. So pure substances, can't separate. Mixtures, you can separate. The next topic that we're going to be talking about today is physical changes and chemical changes. So a physical change is a change in the state, okay, or the phase of matter, if it's a solid, liquid, or gas, or its shape or form. Okay? You change something about it, but you don't change what it is. Okay, so if I take a piece of paper and rip it in half, it's still paper. I just change the shape of it. Okay, if I evaporate water, okay, it's still chemically the same thing. Okay, it's just going from a liquid to a gas. That is a physical change. On the other hand, a chemical change, okay, describes how a new substance can form when substances react with one another. I'm creating a new substance. I'm ending with something that I did not start with. There are 4 things that can tell you if a chemical change has happened. The 4 things that you want to look for to tell if a chemical change occurred is if there was a gas produced. And a lot of times that might not be easy to see if you're looking at a chemical reaction, but you would see that in the form of bubbles. If you see bubbles happening, okay, highly likely that you're looking at a chemical change. Okay. Solid formed, and I'm not talking about freezing something. I'm talking about if I put 2 liquids together and I get a solid, that's a chemical change happening. Okay, that's actually forming what's called a precipitate. That is another piece of evidence for a chemical change. The third thing you can look for is a temperature change. And this is, again, not if you heat it or cool it, but if I mix 2 chemicals together and they get cold, or I mix 2 chemicals together and they get warm. That's evidence that a chemical change has occurred. Okay. The last thing that you can look for to tell you if you've got a chemical change would be a color change. If you put 2 things together and they turn a different color than either one started off with, that would tell you that a chemical change has happened. Now on the bottom of your sheet there are 8 substances or things happening, and I want you to go through and try to identify whether a physical or chemical change, and then include a reason why. So for your reasons why, you might include a piece of evidence for a chemical change, or you might indicate that it is a phase change, going from solid to liquid, or that it's just changing the form. So I want you to go ahead and pause the video and do that right now. All right, now that you've had a chance to think about some of these and decide what they are, we're going to go through and discuss the answers. So the first one is fruit rotting and or forming mold. That would be a chemical change. It is, you can probably smell that. That's another thing you can look for a chemical change. You notice an odor. It's turning a different color. Okay, you might have a different solid being formed. That is a chemical change. Sweat evaporating is a physical change. Evaporation is the key word there. We're going from a liquid to a gas, but we're not changing what the actual object or thing is, so it's a physical change. A car rusting is a chemical change. It's actually reacting with the oxygen in the atmosphere. When you get a color change is a big one to tell you that this is a chemical change. Baking a cake is a chemical change. There are all sorts of reactions that are taking place in that cake. You can't undo it. Okay, that's another good way to tell if it's a physical or chemical change. You can't unbake a cake. Okay. If you bake a cake, it starts to rise. We're forming that solid. That would be an example of a chemical change. Lighting a match, okay, is a chemical change. You get a color change. You get a temperature change that show you that a chemical change has occurred. Ice cream melting. That keyword there is melting. If I melt something, I'm going from a solid to a liquid, but I'm not actually changing what I have. The chemical composition has not changed. I could refreeze it again. I could undo it. That means that it is a physical change. Boiling water is also a physical change. Boiling here is causing evaporation. So I would be going from a liquid to a gas, and that again is a physical change. I'm not changing the composition of what I have. And the other example here, stretching a rubber band would be a physical change. It is a physical change because I'm just changing the shape of it. I'm not actually changing what I have. So we'll go through more examples and discuss this more in class. Okay. But I just wanted to make sure we knew the difference between these. Thanks for watching. Bye.